Let's review Newton's second law of motion. Newton's second law of motion is given by the equation F equals ma, where F is force, m is mass, and a is acceleration. To find the acceleration, we'll need some information. Acceleration is given by a of t equals v prime of t, where v of t is the velocity, so we need to know the velocity. Velocity is given by s prime of t, where s of t is the position, so we also need to know the position of the object in question. As you can see, all of these equations depend on the variable t, which is used to represent time. If we want to use this law in application problems, we need the given force equation to be equal to the force of gravity acting on the object. To find this force equation, we need to have a value for gravity. Near Earth's surface, the acceleration due to gravity is a constant denoted by g that equals 9.8 meters per second squared. When an object is thrown upward, gravity acts in a downward direction, and in that case, the force of gravity is given by F sub g equals negative m times g. Our force equation is then F equals F sub g, or m times v prime of t equals negative m times g. Note that we can divide both sides by m, leaving v prime of t equals negative g. Let's do an example. Suppose we have a ball 2 meters off the ground, and we throw it up toward a hoop that is 10 meters off the ground. We are asked to find the necessary initial velocity for the ball to drop through the hoop. We start with the initial value problem for v prime of t. Given explicitly, we have v prime of t equals negative g, and v at 0 equals v sub 0. This means our initial velocity is v sub 0, which is what we want to solve for. We can take the integral of both sides to get the integral of v prime of t dt is equal to the integral of negative g dt, which gives us v of t equals negative gt plus some constant c. If we plug in 0 for t, which is our initial condition, we get that v of 0 equals c. We already know that v of 0 equals v sub 0. Therefore, we can say that v sub 0 equals c. This means we can rewrite the equation as v of t equals negative gt plus v sub 0. The original question explicitly mentioned two positions, so now we should use our velocity function to create a position function. Recall that the position is s of t, and the velocity is s prime of t. So, the initial value problem for position is s prime of t equals v of t, which equals negative g times t plus v sub 0 with initial condition s of 0 equals 2. To solve this initial value problem, we first take the integral of both sides. This gives us the integral of s prime of t dt equals the integral of negative g times t plus v sub 0 dt. Taking the integral yields s of t equals negative g times t squared over 2 plus v sub 0 times t plus c. If we substitute in 0 for t, we get s of 0 equals c. We also know that the initial condition states that s of 0 equals 2. Therefore, s of 0 equals 2, which equals c. Now we can write the position function as s of t equals negative g times t squared over 2 plus v sub 0 times t plus 2. We know that what goes up must come down. When the ball is at its maximum height, it will have 0 velocity because it is no longer going upward and it is just about to fall back to Earth, hopefully through the hoop. Let t sub b be the time it takes for the ball to achieve its maximum height, and then use our equations for v of t and s of t to solve for v sub 0. At the maximum height of the ball, the velocity will be 0. This will happen after t sub b seconds. This gives us v of t sub b equals 0, which equals negative g times t sub b plus v sub 0. From here we can solve for t sub b to get t sub b equals v sub 0 over g. We started with a ball at a height of 2 meters and threw it toward a hoop that is 10 meters high, and it has taken t sub b seconds to get there. Now we want to find the position function when s of t sub b equals 10. The position function when s of t sub b equals 10 is negative g over 2 times the quantity v sub 0 over g squared plus v sub 0 times v sub 0 over g plus 2. Simplifying, this equals negative v sub 0 squared over 2g plus v sub 0 squared over g plus 2. Subtracting 2 from both sides and noting that the other terms combine, we have 8 equals v sub 0 squared over 2 times g. Solving for v sub 0, we have v sub 0 equals the square root of 16g. This equals 4 times the square root of g. We know that g is equal to 9.8 meters per second squared, so we can plug that value in for g. So, we now have v sub 0 equals 4 times the square root of 9.8, which is approximately equal to 12.522. Therefore, to get the ball up to the hoop, you need an initial velocity of 12.522 meters per second.